Okay, we're going to try this now for algebra, and hopefully this will kind of help give you a refresher course on what we did today in class. Today we talked about 6-5, solving linear inequalities. We're going to be solving these by graphing. You've seen this diagram, well you saw it today, but you've also seen it in the past when we were doing number lines, okay? And you saw maybe something that was x is greater than 6, and so when we had the 0 and the 6, whoops, that should be a 6, and we graphed that, we would say that this sign would give us an open dot, and because it was pointing to the right and the variable was on the left, it would move to the right. These are the new parts, though. Today, instead of graphing it on a number line like this, we're going to be graphing it on a coordinate plane. And the lines that we graph are either going to be dotted like this, or they might be solid. Okay. Both of them, though, should have the arrows. And then what we're also going to be doing is doing some shading. Okay. These are the steps. So basically, keep in mind the dotted lines and the solid lines. Solid lines go with anything that has the equal to in it, and the dotted line is just when it's simply less than or greater than. Our steps are going to be, first we're going to try to put it in slope-intercept form if it's not already in there, because that's the easiest form to graph from. Then we're going to graph for points. Then you're going to, once you get the points, you're going to have to connect those points, and it's either going to be a solid or a dashed line, depending on what it is. So if it's solid, you're going to draw a solid line. If it's dashed, you're going to draw a dashed line. Then you're going to pick a test point. And the test point might be something like that. You're going to plug those coordinates in, and if that makes the region true, then you will shade that test point in. If it makes it false, then you'll shade the other side. It'll look like this. Okay, so these are really our three new steps of the day. So now let's try an example. You're given y is less than 3x plus 4. So that's as close to slope-intercept form as possible. We're going to use that to graph. We know that b is 4 and m is 3 because y equals mx plus b. We can still use this even though it's an inequality. M is going to be 3, b is going to be 4. So b is our y-intercept, so it crosses here at 4, and we're going to be going up 3 over 1, up 3 over 1. So you've got all these points that are right here on this line. Now we need to try to determine, is it going to be a solid line or a dashed line? Because it does not have an equal sign here, it's going to be a dashed line. Okay. We put our arrows like so. And then finally we need to pick a point, a test point, test it, and then shade an appropriate region. We're either going to be shading the left side of this or the right side. The easiest test point is going to be 0, 0. However, you never want to pick a test point that's actually on the line. You want to make sure that it's clearly off the line. 0, 0 is clearly off the line in this case, but if for some reason the line, like if it would have been something like this, then you would have want to try to avoid it for sure. So let's see if I can get this to move now. Back over. Okay, good. Now, we have our point 0, 0. This is our test point. The way we're going to test 0, 0 is by simply taking our original inequality and plugging it in for each variable. We know that this is our x, this is our y. So if we get 0 is less than or equal to 3 times 0 plus 4. So now we plugged them in. So 3 times 0 is 0 plus 4 gives us 4. And we ask ourselves, is 0 less than 4? Well, obviously 0 is less than 4. And so we have found that 0, 0, this does make that statement true. Since it is true, we know that 0, 0 is a part of this solution. And so we're going to shade it saying, yes, that is part of the solution. The shaded region is our solution. Okay, let's try another example. Our second example, unfortunately, this one is not in slope-intercept form, so we're going to need to get it there. The way we're going to do that first is by moving this over, and then we're going to have to get rid of this 2. So first we're going to subtract 3x. These cancel, you're left with 2y is greater than or equal to negative 3x plus 6. Then we're going to have to divide by 2. Remember, the entire thing is being divided by 2. These cancel, you're left with y greater than or equal to negative 3 halves x plus 3. Notice that the 3 did go to both. I took 6 divided by 2 to get 3, negative 3 divided by 2 to get negative 3 halves. We now know that m equals negative 3 halves, and b is 3. So we can go over to positive 3 and put our b, or our y-intercept, and we're going to go down 3 over 2. Down 3 over 2. Okay, let's see if I can create my line. I need to connect the dots. Because it has an equal to sign, we know it's going to be a solid line. Okay, that's not too bad. And then I need to pick my test point. Again, 0, 0 is clearly off the line. That's always the easiest test point to pick, so I'm going to use that. I'm going to go back to my original inequality, and I'm going to plug 0, 0 in for that. Oops. So we get 3 times 0 plus 2 times 0. Is that greater than or equal to 6? We're trying to figure out if it's true or false. 3 times 0 gives us 0, plus the 0, 6. So is 0 greater than or equal to 6? Well, we would say that that's false, because 0 is not bigger than or equal to 6, which means 0, 0, that point, is not part of the solution. Since it's not part of the solution, we can't shade this side, because that would tell us that it is. We have to shade the other side. So we were able to determine that it is a solid line, and that the right side, or the upper right-hand corner, is what needs to be shaded. Okay. Now looking at our last example, making sure that I have time to do it before class gets started. Here we go. It's already in y equals mx plus b form, so we should be able to look right at this and do m equals negative 1. And since it's kind of plus 0, we know b equals 0. So y-intercept is 0, and we're going to go down 1 over 1. Whoops. Okay. It does have the equal to sign, so we know it's going to be a solid line. And now we have to ask ourselves a test point. Well, what we've been using is 0, 0. If I put 0, 0 here, you can see, obviously, it's smack dab on that line. So we need to pick one that's obviously not. 1, 1 is always, I think, the second easiest one. So we're going to use the point 1, 1. We use the original inequality. We plug in 1. Is it less than or equal to negative 1? Well, is 1 less than or equal to negative 1? No. This would be false, because 1 is bigger than negative 1. So that means 1, 1 is not in the solution, so we are going to shade this region. I hope that helps you with section 6-5. Good luck on tonight's homework. Remember, you can email. Also, if this is going too fast, remember you can always rewind it or go ahead and hit the pause button, which should be down here in this region. Good luck.